In this video, we'll write the net ionic equation for H2C2O4 plus NaOH. We have oxalic acid and sodium hydroxide. We have an acid and a base. It's going to be a neutralization reaction. We'll get a salt and water. So the first thing we need to do with net ionic equations, that's balance the molecular equation. I've already balanced the molecular equation here, so that's done. Next, we need to write the state for each substance. So the oxalic acid here, that's an acid. It's a weak acid, but it'll dissolve, so it's aqueous. It won't dissociate very much, though. Sodium hydroxide dissociates into its ions, and then sodium compounds, if you know your solubility rules, they're very soluble, so this will be aqueous, and water is a liquid. So we have the states. Now we're going to split the strong electrolytes into their ions, and this will give us the complete ionic equation. That'll look like this. So I've not written the states here. We'll do that at the end. So for oxalic acid, we don't split that apart. It's a weak acid. We don't split weak acids apart. They don't dissociate very much. So we leave those together. Liquids, we keep those together. But we split everything apart into its ions otherwise. Now we can cross out spectator ions. Spectator ions are on both sides. So we have in the reactants here 2 sodium ions and here in the products. And that's really it. That's the only thing. These are the only spectator ions. That leaves us with the net ionic equation for H2C2O4 plus NaOH. Let me clean this up and add the states. We'll have our net ionic equation. So this is the net ionic equation for oxalic acid and sodium hydroxide. And again, you need to recognize that this is a weak acid, so we don't split it apart. We don't split the water apart either. You note that charge is conserved. We have 2 times 1 minus. That's 2 minus. Then in the products, we have a 2 minus here. And if you count the atoms, they're balanced as well. This is Dr. V with the net ionic equation for H2C2O4 plus NaOH, oxalic acid plus sodium hydroxide. Thanks for watching.